Okay, so previous classes lo manam Power BI environment gurinchi complete ga so we have discussed about the Power BI environment, like how the desktop will be there and how the Power BI service will be there. So what and all things we will do on the desktop and what and all things we will do on the service level. Okay, so now this class is about the project. Okay, so how we deal with the project, it means what all things we get from the clients, and from there, so how we take the project further. It means how we create the report and how we deploy it and how we share with the end users. Okay, so before we start any project, actually, so we will get the business requirement document. We call it as a BRD document. So before we start with the environment, so we should know what is BRD document. BRD is nothing but business requirement document. So I have a test document for you. So in the text document, I'll show you how it is. Project training. So this is the BRD document that I have, and assume that this business is about the supermarkets. So they have a multiple supermarkets all over the world. So from their supermarkets, like we have the information for them, we are creating a report. And in this, if you see, this is the requirement document for us. So it means that there might be multiple reports. If you see, for any business, there are multiple reports. So, and we will not be working on all the reports for them. So if you see, there might be multiple reports, and some of them I can say sales performance dashboard. So for this company, and store performance overview, and customer insight report, and there will be inventory and stock report, and there will be time based sales trend report, and revenue and profitability analysis. There might be multiple reports for the organizations. So we will not be working on all the reports. So sometimes, when you join the organization, so you'll be getting your requirements to create a reports. Okay, just assume that we got a requirement for the sales performance dashboard. It means that they wanted to track the daily, weekly, monthly, and sales performance across the different stores. Okay, and for this, a report, so they will not give the direct details like this. So what they will do means, before they start any project, they will create a business requirement document. They will create a business requirement document. So there will be two kinds of environment. Usually, so we will directly speak with the customer and get the requirements. That is one thing. And another thing is, in between, we will have the business analyst. So we are the developers. In between, business analyst will be there, and then client will be there. Client means the stakeholders. So we have a three levels here. So first, business analyst will contact the clients, and he will get all the requirements, and he will prepare the business requirement document. Accordingly, he will give the estimations, and he will he will assign the developers for the project. So that is the first step. So he will gather all the requirements, and he will prepare the planning for that. It means when it needs to be done, and what is the deadline for that, and what is the time taken, time needed for developing this project, and how many resources are required, and how many developers are needed, how many testers are needed, and all the budget planning and all he will do. Okay, that's business analyst. Okay, unless you are directly working for a client. So if you are working in this kind of environment, it means where we have the developers and business analyst and the client. So business analyst will take care of all these things. Okay, in some cases we directly get the requirement from the client, so based on some document. So with that document, we will be creating, we'll only give the estimations for it. It means this project will take this much time and all. We will give the estimations. Accordingly, we'll start working on that. So first thing we need is business requirement document. So that can be from direct client, or that can be from the business analyst. So when you have the business analyst, right, you will not have much scope to speak to the client directly. So you have to interact with the business analyst, and he will talk to the client and get the, even he'll be working as the mediator in between you and the client. So when you have the business analyst, so when you are directly speaking to the customer, so you can ask all the doubts, or you can ask all the documents, or whatever the data sources and all they are using. So you can get all these things. So in this case, assume that we have the business analyst, and he got all the requirements from the user, and he documented it. It means he created a business requirement document. So before starting any project, we need this document. And so if you see, so this is the project name here. So for this client, is XYZ supermarket. So they are asking us to develop the sales performance dashboard. Okay. So for this, developing this sales performance dashboard, so assume that so maybe marketing team or sales team. So ask you to develop this report. So they are the requesters. So for them, we are developing this report and the date when it is created and what is the scope of the project. It means what they are trying to analyze or maybe what kind of information they wanted to see. So this is the objective and this is the description about the project. So this information we will have from the BRD document. It means business requirement document. So this now document is must. So what they wanted to, it means what is the objective of that project and so what is the description of the project. It means what exactly you wanted, I mean, you are representing over there. So this kind of information will be there. Okay, so project overview, requester, date, and all these details will be there in the. So when you are following a structured manner, so you'll have all these things. After that, we'll get into the page level. It means so we'll have multiple pages in a report, right? So at each page level, they will give you the requirement. It means what page they wanted to see and what kind of KPIs they wanted to see over there. So what is the logic for them? It means logic in the sense it is not a DAX logic. So they will give you the business logic. So if I say sales, total sales. So what is the logic for that? Sum of sales column. It means sum of sales. So like that, the business logic will be there. So if they wanted to perform the, for example, if you see, so we have a different pages here. So this was the high level information and this is the page level information. So what KPIs they wanted to see at each page level. So first one is the core sales metrics. So this is the first page. And in that page, they wanted to see all these KPIs like total sales amount, total orders, and total quantity, sales growth or, percentage month over month. So this kind of information and all they are trying to see. And for that, so these are the business logic. It means what is the, it means they'll not give the direct column names here. Simply they will mention, so sum of sales, so like that. And so what is the account of sales ID? So like that, they will give you the business logic. It means according to the data. And based on this, what we will do means we will go for the development. It means we will prepare the environment first and then we'll get into the actual development. So if you observe this document, there are multiple pages like core sales metrics, and this is representing total sales amount, total orders, total quantity sold, sales growth percentage month over month, and sales growth year over year, and average order value, average items per order, and then sales per day, and sales target achievement, and percentage of discount, the discounted orders, and percentage of revenue from discounted sales. All these information, all these KPIs they wanted to see, and these are the respective business logic for them. Okay, and then when it comes to channel performance, see this is the second page, and in the second page what they wanted to see, like online sales amount and store sales amount, online store or order count, and AOV like online versus store, and channel revenue share. So it means sometimes we are not sure about the terminologies, like what exactly it means. So we can search over the internet or we can ask the user what exactly this meaning, and the respective description will be there on the right side. So you'll get the description sometimes, and if you are not familiar with that, so you can ask the user. It means if the description is not specified, so you can ask for the logics. And if you are not familiar with the logic, it means if you're not understanding also, you can talk to the clients and you can get clarification on that. Accordingly, you can choose the columns. Okay, and when it comes to next page, so we have the category and the product metrics like KPIs, top 5 or bottom 5 products by sale, top 5 or bottom 5 categories by quantity. So these are the sales by category, the sales return percentage, and average selling price, sales by margin group. So we have all these information. It means they are expecting all these KPIs, and these are the expected pages. In each page, they are expecting the KPIs, and these are the business logics for them. So what is the business logic? Calculation logic. And after that, on top of the pages, right, they are expecting these functionalities. It means they are asking us to have these filters cap. Maybe that can be slices or that can be separated. We have the filters pane, right? So they're asking us to keep the filters for the first page. So these are the filters they are asking. And for this, toggles, right? Maybe if you want to switch between the toggles, it means a profit view or sales view. It means if you want to switch the dashboard, it means dynamic functionality. So in that case, so they are expecting the toggles, and then bookmark, the sales summary, and the profitability summary. So maybe this bookmark can be for the other pages. It means that can be a page navigation, or that can be kind of a filter. So it means setting up the filters. So bookmarks can be anything, right? We can capture the moments and assign it to them. So according to their requirement, we'll create the bookmarks and assign it to buttons. And page navigation. So apart from that, we are expecting the page navigations also. It means they wanted to navigate to category metrics and the channel performance. Like we have the other pages, right? They wanted to navigate from here. So we need to keep a buttons on the page so that they can navigate from here to that page like that. So these are the expectations and the hierarchies. So if I say date, if you are taking any chart with the date parameters, it means a date column. So they are expecting to create the hierarchies for that. It means they want to see the data at different hierarchy levels. It means day level, week level, month level, like that. They wanted to see the data. Yeah. So that is how they are expecting us to create the document, I mean, a report. So this is the requirement document for us. So all these are the requirement document. So we have the KPIs list and the respective business logic. And so what are the other expectations apart from the KPIs? It means to have the more interactivity. So to have the interactivity, they are expecting us to keep the filters, toggles, bookmarks, and page navigations, and then hierarchies, and then drill downs also. So it means product category, subcategory, like we have the different drill down side. They are expecting us to keep all the values. It means to keep all the, I mean, interactions, the interactive things, so that so they can interactively choose the values whatever they want. It means they can apply the filters, they can choose the bookmarks, they can choose the page navigations, and they can go to the respective views, and they can see the detailed information. So this is the requirement document that we will get from the analyst or from the end user, it means from the client. So based on this requirement document, we have to identify which tables we need for this. For developing this is like which tables we need and all, we have to identify. So for that, we will have the database, right? So in the database, we have to search for the related tables. Okay, so we'll have the when for each business they will have the data warehouse, and in the data warehouse they'll be maintaining all the tables for that. And in the same way, we have the database like this. So just assume that this is the warehouse for us, and here we have all the information. If you see, we have the store information, we have the product information, and we have the employee. I mean, so this is different. And yeah, fact sales is there, right? So this is the sales information and HR related information, inventory stock details information. So out of all these tables, whatever required for creating this metrics, right? So it means this KPIs, we will be pulling all the tables into the Power BI desktop. So that is first thing. So first thing is what requirement we have to analyze from the document or from the user. We need to analyze the requirement, and then we have to identify the respective tables for creating the KPIs. It means whatever KPIs we have, right, to create them, what all tables we need to identify. So if you see, we have the category dimension and channel dimension and customer dimension, date dimension, and then employee details if we have, and then product details and store details. So we have the dimension tables along with the fact table. So if you see, all the facts, transactional information will be stored into the fact table. So we have to identify the respective information based on the document. So customer ID, quantity, order details, all these are they're expecting. So I think I have the document. Let me check once. Yeah, I just identified the schema for that. It means what all tables we need for this requirement, right? So I've identified based on the columns and all we have. So we have to identify the respective tables. So here I need a customer table and product table and store table, employee table and date table and channel table, and then category. So these are all the tables that I need to create this requirement. It means based on the columns, right, in the specified document, so you can identify. It means based on the business logic. So you have to focus on that and identify the respective tables. It means where we have that information. If you see in the fact table, we will have all the transactional information. So it means the IDs will be there, like customer ID, product ID, channel ID, everything will be there. But the respective dimension tables we have to identify. So if I am talking about the store details, so we will have the store dimension table. So if you have the store ID means, so if they are talking about anything on the business requirement document about the store, we have to we have to import the store table. It means dim store table into the model. And then sales table. After that we have the customer table. So we have the customer wise information over there, right? So we need to get the customer details also. Where we will have the customer details in the customer dimension. I told you right while explaining the model. So we will have the dimension table for each category, and then the respective transactional information will be there in the fact table. So according to the information that they are asking, so whether it is a customer wise or a product wise or a store wise, so accordingly you have to import the respective dimension tables. Okay. And so, however, fact table will have all the IDs for them. So, accordingly, you have to import the dimension tables. So, here in this case, I need a product dimension. I'll just take this. So, I need a product dimension, customer, and dim store. Store details, employee details, date details. So, if we have the date, if we don't have the date, means we have to create in the Power BI using the calendar function. So calendar or calendar auto function we can use, and we can create it. So for the continuity of the dates, and then channel is there, and then category is there. So for that, I'll try to import all these tables into Power BI desktop. So first we need to keep the environment ready. It means we need a Power BI desktop, and then we need a Power BI service. Once we are done with the development, we will publish into Power BI service, right? So first we need a Power BI desktop. So I think I already opened it. Okay, so assume that I have identified all the required tables for this requirement. Now I will connect to the database. So before connecting to the database, I'll clear the credentials so that you'll see like how it will be while accessing for the first time. Okay, now first we need to connect to the server. So how we will connect to the server? Get data, and my data warehouse is SQL server in this case. So I have to connect to the SQL server and then give the server name. So this is my server name. Copy and then server name. So, and if you want to write any query, you have to specify the database name, and then you can write it. It means if you want to pull the product table, select star from product table. And if you want to pull the data from customer table, select star from dim customer or whatever name we have on the source. So I want to select all the dimension tables directly here. So that's why I'm not writing any database name and writing any statement. So maybe that depends on your project. Like if you want to write a query, you can write it, or you can directly select the tables. So when you want to cut down the data, it means whatever data that you want to import, it means instead of pulling all the data, then you have to write the queries and restrict the data so that we can improve the performance. So in this case, I have a less data only. That's why I'm directly selecting the tables. So I'll go to the next step. So it will ask for the authentication. Okay. Most of the times you'll have the database. It means you have to give the username and password. And sometimes they will connect you. They will connect your account. It means your network account to this database. It means once you log in, once you join to the organization, they will create a mail ID with their organization email ID. So with that domain actually. So if you log in with that, it will be enough. Like you don't need a separate username and password. So you can directly click on sign in and give the network credentials. We call them as the network credentials. It means network email ID and credentials. You will log in with that. So otherwise, they will give you the username and password. Then click on connect. Click on connect. Then it will take you to the respective database, database list. So there you can identify the proper database, and then you can select the respective tables you want. So what all tables I have identified for this requirement is from the training database. So I have identified these many tables. It means dim product, customer, store, employee. So first we'll select product, customer, store, employee, and then date, channel, category. So these all tables I have identified. Channel, category, and then date. So these are all the tables I need. So these are the dimension tables I need, and I will load them. So and when it comes to fact table, this is the fact table I have. So fact sales is there. I need that fact table also. So usually when it comes to fact table, we'll have the a lot of information in it. It means from the start of that business, there will be so many records. So that time you have to specify the where condition. It means if this dashboard is for the last, if it is referring to the last 3 years or last 2 years now, you have to specify the transaction. It means you should specify some filters on the transaction date. So we will see like what date we have here. When it comes to select star from fact sales, I will take. Yeah, so these all details we have, and this is the date ID. Okay, so based on this data ID, you can restrict the data. It means you can put where condition and you can specify the dates, and maybe you can take the last 3 years data from the system date. Today, I mean, dates between you can specify, and today's date, I mean, today minus 365, maybe if it is only 1 year data. So, and today, so if you get data, if it is SQL, so it is a get date, not today. If it is lakhs, it is today. Okay, you have to specify the get date, so it will give the or sys date. Sys date will be there. So sys date minus 365, dates between where date, dates, date column will be there, right? So we have to specify that condition, dates between and start date. Start date will be last, last year, right? Last year same time. So to, I mean, sys date minus 365 and sys date, so that it will pick the dates between that, and the date should be whatever the date column, date ID is there, right? It should be between this date and that date. Okay, so then it will take the transactions for that. So now I have this fact sales table. So I have to import the sales table also. So how do I do that? So you have to write a query for that. It means you cannot import all the data at a time. So you write a query for that. So in this case, I have very less data. So I'm trying to pull all the data. I mean, all the table. So training and fact sales. Okay. So if you have any transformations, right? So you have to do the transformations first. So since it is a structured data, I don't have any transformation. So otherwise, so you have to do the transformations in the Power Query editor. Like if you want to
హలో
combine the columns.
మహేష్ బ్రో,
Yeah, చెప్పండి.
మాకు స్క్రీన్ పైన ఏదో ఒక బార్ లాగా వస్తా ఉంది, అది సరిగా విజిబుల్ కావట్లేదు
Okay. Yeah.
ఆన్లైన్.
One second, I'll just try to reshare it. Yeah, is it okay now?
యా బ్రో, ఇప్పుడు బాగుంది.
Perfect. So I have imported the sales table also. Now, if you have any transformations, I told you that workflow, right? Like how we, follow that. So first thing is like we need to identify the requirements. After that, what is the first step? We have to import the respective tables. So in the first step, I have imported the respective tables for this requirement. So that is what we have to do. And then in the second step, what we will do? We need to complete the transformations. So if we need any transformations for this requirement, so we have to complete the transformations. It means where we will do the transformations in the Power Query editor. So we'll go to the Power Query editor and we do the transformations. It means maybe removing the unnecessary columns, or renaming it, or maybe creating the additional columns, maybe generating the index column. So according to this requirement, if we need any additional columns, or if you want to modify the existing thing, or if you want to update anything, you want to replace it, or you want to split the column into multiple columns. So for now, I don't need any transformation since I have the structured data. So when you are dealing with Excel cell, I mean Excel data and all, right? So you may need to perform some transformations on it to properly shape it up. So in this case, it's all structured data. Why? Because I'm taking from the database, right? So almost, I mean, it is processed and it is saved over there. So I don't need to do any transformations on top of this. But if you get any Excel data, CSV, or any kind of a SharePoint information and all, so you may need to perform some transformation. So final thing is the data should be like this. It means it should be structured. So we should not have any unwanted data. So we should have the proper structured data. It means there should not be any errors in it. And if you want to split the columns, or replace any values, so you have to perform all these things. Okay, so when you are accessing the number columns from the Excel file. So sometimes they'll specify some NA values. It means not applicable like that. So if you don't have the value for the specific cell, so that NA, because of that NA value, Power BI will treat that column as the text column, but it should be a number column. So if it is a text column, you cannot perform any calculations on that. So in that case, what you have to do, you have to forcefully change the column name, column data type into whole number or decimal number according to the values that you have. So if you are changing that, all that NA values will be converted as the errors, because that is the text value, right? So text values cannot be converted into numbers. So in that case, so you right click on it and click on replace errors. You can replace the errors with a null value, or you can replace with 0, so that your calculation will not affect. Okay. So like that, we'll do to some transformations. Maybe if you want to combine multiple tables and get the data into a single table, so you can use the append queries or merge queries. So it depends on like how we have the schema. So it means if you want to combine on a column basis, you have to use the merge queries using different joins. We will get the data into a single table. We have different joins, right? Like left join, right join, inner join, full outer join, left anti-join, and right anti-join. So out of that, we'll use inner join and left anti-join most of the times. And then if you have the same structured tables, and if you want to bring all the information into a single table, then you have to use the append queries. It means employee, we have two branches. So for branch one, we have one employee list, and for branch two, we have another employee list. So we wanted to bring all the employees list into single lists. How we can do that? So we'll take the table one, table two, and use the append queries and bring all the information into a single table. So that is for append queries. It means we do the required transformation. So if your headers are not in the first line, if you are taking in the from the Excel, so then you have to pop up the headers for that. It means that you have to convert the column names. So how we can convert the first row as the column names means we have to use first row as column names. So most of the times when you are using Excel files, right, we need so many transformations. So if it is a database side, we don't need that many transformations unless there is a specific requirement to create a new column or to update the values inside it. So we don't need to do any transformations. Okay. Now in the second step, so as per the workflow, we have to complete the transformations if any needed. Then we will get into the model. So we have to identify the relationships among these tables. So then we will create a schema. So where we will do the modeling? Model view. It means what is the component name here? Power pivot. So in the power pivot, we do the modeling. So when it comes to transformation, what is the component?
Power query.
Power query editor. So in the power query editor, we do the transformations. And in the power pivot, we do the model. Just remember that. So automatically it has detected some relationships. I don't want them. I want to create on my own. Maybe some might be correct and some might be incorrect. So that's why I'm deleting all of them and I'll create relationships again. So now we have the proper data. It means we have the dimension table and the fact tables. So now what we will do means most of the times we'll prefer to have the star schema. Star schema, it means we will have the centralized fact table and we will, it will be surrounded by the dimension tables. So snowflake schema in the sense tables are connected in a sequence. It means we will have the dimension tables and subdimension tables and subdimension tables like that. It means the fact table is not directly connected to the subdimension table. In between, we will have the dimension table and then another dimension, subdimension table like that. They are connected in a sequence. So here more number of joins will be involved. Okay, so here normalized data will be there. It means they wanted to remove the duplicates and all. But in this case, even though the model size is reduced, but the performance will get slower. It means the performance will be impacted when you have the snowflake schema. So usually if you want to store the data, it means in the databases, right? So for storing purpose and all, we can have we can reduce the redundancy. It means the duplicates and all we can remove, and we can create the dimension tables, subdimension tables and all, and we can create a snowflake schema. So because of that, we can reduce the model size. But if you want to access the fact information from the fact table, so the subdimension cannot directly access the fact table. It has to come through the dimension tables in between. So there will be more number of joins in between. That is why That is why we prefer to use the star schema. Since we have the more number of joins in the snowflake schema, so the performance will be slower. But when it comes to star schema, we will have the fact table and respective dimension tables. So the dimension tables will be connected with the fact table directly. It means there won't be any sub dimensions again. So directly the dimension tables are connected to fact table. So the fact table is surrounded by dimension tables. All are connected with a single join. It means single relationship. So we don't have any sequence of relationships. So in this case, because of only single join, so we will have the, it means for each dimension table with the fact table, we will have the good performance. When it comes to Power BI, star schema will give the good performance. So always we prefer to have the star schema. Then when it comes to this case, so we have the fact table and this is the fact table that we have, and these are all the dimension tables. So these are all the dimension tables we have. So we'll try to build the relationship among them. We'll try to identify what is the, foreign key and what is the primary key among them. Then we will create the report out of that. So these are all the tables that I have. So just analyze these tables, what all information we have. So already we analyzed in the database and we brought all these tables. So after seeing like what columns we have and what details we have and all we have seen, and accordingly we have imported these tables. And if you want to analyze further, you come into data view, this table view. Here you can go to each and every table and you can analyze it. So when it comes to fact table, how many rows I have? It means how many transactions I have? I have 1003 transactions. Okay. Out of that, if we observe, I have the sales ID, product ID, and the customer ID, store ID. It means in which store it has happened. The transaction happened, and employee ID, who made the transaction. It means maybe the billing person, or the channel ID. It means the channel means like we have the this one, online or store. So sometimes like we will have the online purchases and sometimes we will have the store purchases. So we have the channel ID as well. And store ID means so based on the store ID, we can get the store information from the store table. So we have the store ID, store name, location, and then square footage, something like what is the square feet of that table. It's just maybe the area of the store. So we have the store information. And so based on the store ID, we can fetch the store information from the store table. And then so we have the employee ID. Maybe if you want to fetch the employee information, like who is the employee name and in which store it is and all, you can fetch it. Like employee name and all, you can fetch from there. And when it comes to product ID, so based on the product ID, we can get the product descriptions from the product table. It means what is the product name, what is the category for that, and what is the unit price for that. So in this case, so we have the category as well. So I don't think we have that table here. Mhm. Okay, category is there. I think I missed it. So I'll get that table also. SQL Server, just specify the server name. So second time onwards, it won't ask you for the authentication. So okay, so now I got all the table. Just forget about the category for now. I'll tell you like what we can do with that. So I'm observing all the data related to sales. So now we have the, so we have seen store details, employee details, and product details. So where we can fetch, all these details means based on the store ID, we can fetch the data from the store team store table. And for the employee details, based on employee ID, we can fetch from the dim employee. And for the product information, so you can fetch it from the dim product based on the product ID. Okay, so we have the, so this is what is this key actually? The store ID. This is the primary key in this case. It means for the dimension tables, the store ID is the primary key. And when it comes to fact table, the store ID is the foreign key. Why? Because so we're using this, sorry, this is the store ID, right? Using this, we are trying to build the relationship and fetch the related information from the other table. So if you are using this table, key for building the relationship with the other table, we call it as the foreign key. So in this case, it is foreign key, but when it comes to store dimension, it is the primary key. Just remember that. So same for the product also. Product ID here in the product table is primary key, and the same product ID in the fact table, it is foreign key. So using that, we'll build the relationship with the product table. So we have the date ID as well. So instead of giving the direct dates, I think they have created a date ID. So if you want to get the full date, we have to fetch it from the full date. So instead of joining based on the date transaction date, they are creating IDs over there. So that is also on kind of a standard. So they will create a date ID instead of the full date. So that will join it based on the date ID, and then we can fetch the full date or day, month name and all from the date table. Okay, so this is the schema that we have. It means these are the tables we have. Now, based on these tables, we have to build the relationship. So if you don't have the direct relationship, it means for your requirement, so assume that you have two tables. So it means left table and right table. And you have some information in the left table and some information in the right table. For example, so the fact table, you have the, product information, and, assume that we don't have the product ID. And just maybe we have the product name or maybe category or anything. So just assume that we have that columns and we don't have the direct product ID. And if you want to put the, if you want to fetch the product details from this, it means what is the unit price and what is the other details maybe from the product. So that time when you don't have the direct relationship, you try to identify some pattern between them. So based on that, we create a concatenated key and create the relationship. So for that product, it will fetch the exact product name and exact unit price and exact details from this when you don't have the direct relationship. And if you are not able to build the direct relationship, then you can contact the DB team or any other team who is handling this data, so that you can have the relationship and you can fetch the related data. So just analyze if there is a possibility, so that I can fetch the, for example, if I say Coca-Cola, so it has to fetch this value only from that table. So for that you need a pattern. It means you need a key for that. It means for building the relationship. If you don't have the direct product ID, maybe if there is any alternate key, or with the combination of two keys, maybe concatenated key, if you can build a relationship so that it can point to this product name, just identify if there is any pattern, then create the relationship. It means first you create the concatenated key, then you establish the relationship. So now we have identified, like we have the sales table, sales table, and for the, like we have the foreign keys. So using that foreign keys, we have to fetch the, we have to build the relationship with the respective dimension tables. So then we will get into the modeling. Then we will build the relationships for them. So first we'll go to manage relationships. Then, so the first table is fact sales, or else we'll take the dimension table. So we'll start with product. Okay, so product dimension I'm taking, and the second table is the sales table. So that is the fact table. So the relationship should be on which column between these two? Product ID and the product ID. And what is the cardinality? Which is the dimension table and which is the fact table? Product is the dimension table and this is the fact table. Sales is the fact, sales is the fact table. So when it comes to cardinality, what should be the cardinality from dimension to fact? Dimension to fact. So which side we will have duplicates and which side we will have the unique values? So dim table side we will have the unique values, and on the fact table side we will have the duplicates, because the same product, multiple people can purchase the same product. So multiple times we will have the same product ID. But in the product table, so with the same product ID, we will not have the multiple products. It means like assigning the same employee ID to multiple employees. So there will be ambiguity. So that should not be the case. There should be only one employee ID for the employee. So the same employee ID should not be assigned to the other employee. It means maybe another employee. So in the same way, so one product ID should be there to the one product only. It means it should not be assigned to any other product. So in that case, when it comes to product table, we will have one product ID and the respective product information for each product. Okay, but when it comes to fact table, for the same product, we will have the multiple purchases. So the same ID can be repeated multiple times, like same 101. That means, for example, if the person is purchasing the Coca-Cola 1 liter, so another person can also purchase the same product. So in that case, the same ID will be repeated again. So that's why there are chances of having the duplicates on the fact table. So when you have the duplicates, the cardinality should be many. when you have the duplicates, that side the cardinality will be many. So when you don't have the, it means if you just know that you are taking a dimension table, on the dimension table side, there should not be any duplicates. So in that case, it should be 1. So now the cardinality from dimension to fact. Dimension means there won't be any duplicates. Just remember that. Just to confuse you, they'll ask you in the interview, like what is the cardinality from dimension to fact. So if you are speaking about the dimension, you are speaking about the primary key. So the primary key will not have any duplicates. So the cardinality will be 1 to many. So on the fact table side, we will have the foreign key. Clear? And then now after this, we will have the fact table. It means the cardinality will be 1 to many in this case, and the filtering direction. It means the dimension table should have the filtering capability. I mean, to filter the sales table. So we will opt for the single. So by default, we will have the single direction. And if you want to enable the fact table to filter the dimension table, it means a dimension table wanted to filter the fact table, and you want to enable the fact table to filter the dimension table. Then it means if the filtering capability should be in both ways, means then you have to set up both ways. But most of the cases when you are speaking with the, when we are talking about the dimension table and fact table, we will choose a single only. So then dimension table should have the filtering capability to filter fact table. So that is how the relationship should be. Okay, now this is the cross filtering direction. So this is like, filtering capability from dimension table to fact table. So then we will set up. So we will identify the, relationship column between these two, and then set up the cardinality. So dimension to fact or fact to dimension. If I say fact to dimension, then what is the cardinality? What is the cardinality from fact to dimension? Many to 1. Exactly. So it should be many to 1. Just remember that. So you have to set up the, so if you are taking fact table first and dimension table next, then the, cardinality should be many to, I mean, dimension first and fact next means 1 to many. Fact first and dimension next means many to 1. Yeah, that is the exact. Many to many will not establish it. Okay, so now we have created one relationship, and we will see how it is here. See, between fact table and dimension table, I mean fact sales and the dimension product, we have created the relationship. So this is this one. So from dimension to fact, this is 1 to many. If I say fact to dimension, it is many to 1. And if you see the single direction I set up, right? So dimension table is able to filter the fact table. Like that, you have to identify the respective relationship for the tables. So I'm here from the store to fact table. So what is the relationship? So first I will take a new relationship, then I'll take the store table, then I'll take the fact sales. So based on which column? Store ID. So we will put the relationship, and it will be 1 to many, because dimension table first and fact table second. We are taking like that. And then cross filtering direction should be single. So close. So with the store table and product table, we have created the relationships. Then so we have the customer information. So the customer ID and customer ID, will create that also. So once you are familiar with the relationships, right? So you already know that there will be dimension, a primary key, and here it will be the foreign key. So every time we don't need to go to the manage relationships. If you are already familiar with the data, simply you can drag and drop the columns. See, here it is customer ID. You have to drop it on the customer ID only. You should not drop it on the channel ID or any other places. So it will not give the correct relationship. So now if you go to this relationship, if you double click on it, it will take you to here. See, customer ID and customer ID, fact sales and customers. Now it has a fact first and then dimension next. So the cardinality will be many to 1, and this filtering direction is single. You have to create the relationship like this. And from the employee, so you have to create the relationship on the employee ID. Yeah, so 1 to many and single. Cross filtering direction. And from the channel, it means what type of mode it is, like online or store purchase. So you want to purchase and analyze that, then you have to give the relationship on the channel ID. Clear? So you have to give the relationship on the channel ID. And then from the dim date, it will be on the date ID, because we have the transaction date here, right? So usually instead of date, they will have the transaction date on the fact table, and here only direct date. It means instead of full date, they will have the date value over there. So if you have the date ID, you join it on the date ID. If you have the transaction date directly without date ID, so join it on the transaction date and date here. So now I have the date ID. So it depends on the standards, like how the company is following. You'll have the transaction date and here the date, date column. So you have to combine, create the relationship for this. And if you observe this one, so now we have built the star schema. Now we have the fact table and it is surrounded by multiple dimension tables. In this case, if you observe, we have another table called category. So can you see any column in the fact table that can decide the category? We have any category ID column? It means the product will be there, right? So the product can be, if we take a supermarket, there are multiple sections, multiple departments. So it means a grocery section will be there, or some other, baby section will be there, or, a different, beauty section will be there. So there will be different departments out of that. So this category is nothing but those departments only. Okay. So how you are segregating the data here? So based on the product, you are deciding which category it belongs to. Clear? So if you are deciding based on the product category, product value, so we cannot get that information from the sales table. So how you can segregate the data now based on the product? It means what product it is. So where we have the product information now? So in the dim product actually. So this is the dimension table where we have the product information. So here we are identifying the category based on the category ID. It means to which category it belongs to. So in this case, we already built the star schema, but in some cases, what will happen, right? The schema will go out of our control because the client asked us to have the category wise information also. It means they wanted to see each department wise sales. It means the category wise information as well. It means what is the grocery information, or what is the baby or toys or information. It means the sales information and all. So if they are asking her, so they are indirectly asking us to bring the category table as well. So if I take the category, so I cannot create a relationship with the fact table. It means it is not directly related to the fact table. It means the transactions. So in the transaction table, what you will capture? You will capture what is the product ID. It means what product they are purchasing. But what is the category of that product? How you will decide? So you will have the separate product dimension table. There you will have the category ID, and you will put the relationship with the category table. Then you will fetch the related category. It means if I say Coca-Cola, so what is the category for that? Dim category. See, it is the beverages. And then we have the snacks and we have the household. Different categories are there, but they wanted to see the sales value for the beverages, snacks, and households. So different information. But so do we have this category on the fact table? Means we will not directly have it because we are segregating the products into different categories. So we have to build the relationship with the product then. So if they want to see the product, category wise information, first it has to connect with the product, and the product table needs to be connected with the sales table. So if I access the category beverages, it means if I want to see the beverages total sales, so what it will do means, so from this table it will take the beverages name and it will pick the category ID for that. So this is the one, and it will search for the category ID one in the product table. So this is the one. It will first search for the category ID one. So these are all the records that are having the category ID one. It means all these comes under the beverages, and it is connected to fact table, right? It means the direct fact table based on the product ID. So it will identify all the product IDs that are filtered for the category ID one. So these are all the product IDs. It means 172 and 180, 170, 168. So it will search for all these products in the fact table and filter for them, and it will give the sales information in the front end. That is how the filtering will work. It means the category table will filter the product table first, and the product table will filter the sales table. So indirectly, so it is connecting. So it comes under the snowflake now. It means if we have this kind of relationships, right? So it will become the snowflake. So we prefer to build the star schema, but in some cases we will lose the control of the model. So this is one kind of a example for that. So almost we have the star schema, but according to the client requirement, we need to add the category information as well. Since we don't have the direct relationship with the product table, fact table, we are bringing the product table in between, and then creating the relationship with the fact table. It means category is connected to product and product is connected to sales table. Fact sales table. So we have the indirect relationship with that. So how we will create that relationship? So we already have the, if it means if they are asking the product wise information, directly we can take from the product table itself and we can give the sales information. But they are expecting to have the category wise information. So category direct cannot directly interact with the sales table. So that's why. So we'll have the category ID connected with the category ID in the product table. So now we created the relationship. If I pick one here, so all the products that are related to category one will be filtered. And for the same products, it will filter the data in the sales table. It means what all product IDs we will have, right, for the category ID one. So it will filter them in the sales table. So then we will have the sales information for the category as well. Clear? So this is how we build the model. So we have to identify. It means first we need to get the business requirement document, and this is the business requirement document. And from the business requirement document, we will analyze what is the dashboard and what all the, what is the objective and description and what pages he is expecting, and in each page what are the KPIs he is expecting. It means the customer what KPIs he is expecting and what is the business logic for that. So based on this logics, what you have to do means we have to identify the respective tables on the database. Okay, so we have to identify the database tables. So if you observe, these are the database tables that we have. Out of that, we have unwanted information as well. There will be so many tables in the data. So based on the KPIs he is expecting, so we have to identify respective dimension tables and the fact tables. So in this case, we have the customer, channel, category, and then employee, product, store. It means these are the dimension tables. And then we have the fact sales. So these are the required tables for us to build the relationships, because they have asked the category wise information, product wise information, and customer wise information. All these details they have asked in the business requirement document. If you see this, see mode online or offline. So it means based on which channel, a online channel or offline channel. It means the store channel, like how they are purchasing the product. That is that information is there, and the product wise information is there, and they are expecting the categories also. So category wise information they are asking, and the customers, unique customers, new customers, this customer information also they are asking, and the sales information they are asking, quantity information. So all these details they are asking. That is why I have imported all the related tables for this particular requirement. Okay, so how we will import those tables in the Power BI desktop using the get data. We will connect to the respective server and give the server name. And if you're writing a queries, give the database name and write the queries here, or you go to the next step and select the required database and the required tables. We just import all of them. Okay, and the mode we prefer is import for the good performance. So if the fact table is right, having a huge data, and if you want to create our report out of that, we have to connect the fact table in the direct query. All the other dimension tables you can take in the import mode only, because the dimension table will not have that much information. So better to have the dimension tables here only. So then we can create the direct query with the fact table. Okay, so we'll choose the direct query mode for the fact table and then bring the related information here. Then it will process it, and after that, if we have any transformations, we have to perform the transformations in the Power Query. That is the second step. It means after importing all the data, and in the next step, we have to build the model. So in the Power Pivot, we will be building the model. So it means we have to connect all the related tables. So when we have the related information, then on top of that, we will be creating the report. Okay, so
Mahesh
tomorrow
bro.
we'll get into the report. So tomorrow I'll create, yeah, 1 second. So tomorrow I'll create the report for you, and I mean maybe 1 or 2 pages I'll create. After that I'll publish into service, and how we set up the gateway, how we set up the refresh, and how we include it in app, and how we'll share it. So till that process, I'll show you like the complete report. Till as of now, we are seeing, analyzing the business requirement document, importing the related tables, and doing the transformations if required, and creating the model. So this is the process that we follow while developing any report. Clear? Now you ask me if you have any doubts. Yeah. That is what actually when you star scheme means the fact table is connected by multiple dimension tables. Okay, so if the dimensions are tables are broken into sub dimensions, see like this, it means we have the product and we have the category. So this is the sub dimension for this again. So it means we have the fact table and then dimensions are broken into sub dimensions. So it means now if you see, the category is not connected to sales table directly. It is connected through the product table. Okay, so it is connected. It means we have the sub dimensions in between. So because of this, it means we have two different, I mean, two joins here. In the other cases we have only one join, but in this case we have two joins. It means so the category is connected to product and product is connected to sales. So it means the sequence of joins we have involved here. So in this case, we'll consider it as the snowflake schema when we have all the tables connected to dimension tables and the dimension, dimension tables, sub-dimensions to, it means the fact table means, it means the granularity will be there. So in that case, we'll consider that as a snowflake schema. But in this case, it means if you don't have the category, so we can directly say it as the star schema. Since we have the category table additional, we cannot comment it as like a star schema. Of course, snowflake schema is also kind of a star schema, but in the direct star schema, we'll have the fact table and the dimension table with the single join. Yeah, you can ask me online if you have any doubts.
యా బ్రో, పవర్ క్వరీ ఎడిటర్లో
Uh-huh.
ఎడిట్ చేయడానికి మనకు పర్మిషన్ ఉంటుందా?
Yeah,
Without
obviously, like మనకు ఉంటుంది కదా. I mean, we'll have that permission. So yeah, now in this case also, if I have imported the data from the database, right? So if you want to update any information, for example, um, so I want to rename this gender as just G. So I can rename it. If I want to remove this column, I can remove it. So all the permissions will be there. So you can do that.
ఓకే, ఇది మెయిన్ డేటాకి ఎఫెక్ట్ అవుతుందా లేదా bro?
I
మనం
mean, it
ఎడిట్
will
చేసి
be main database means it will not write back to the database. It is just a copy of the table from the database. Just remember that. So whatever you do on the Power Query side or the Power BI side, it will not affect in the database. Database in the sense this SQL server. So it will not affect this table. So we don't have the write back functionality here. It will write back to the database. Unlike like other visualization tools. So whatever you are doing here, right? So it means you are just taking a copy of the data from the server, and top of that copy, you are doing the transformations. Just remember that. Whatever
Okay.
transformation you want, you can do, and you can undo the transformations also by removing these steps.
ఓకే.
Yeah, it will not affect the database. Yeah. Any other doubts? So okay, guys. So tomorrow we'll connect one more time and we'll finish it off. Thank you all.
ఓకే బ్రో, థ్యాంక్ యూ.